Okay, I'm back. I'm going to do the second example in chapter 7. So now I'm on page 22, example 2. And this one's a little bit trickier, so I have already entered all this data in the calculator, but I need to explain to you exactly what we're doing. It says it's difficult to accurately determine a person's body fat percent without immersing him or her in water. Researchers hoping to find ways to make a good estimate immersed 20 male subjects, then measured their waists and recorded their weights. Which variable is more appropriate to use to predict? So we are predicting body fat, okay? So this is my Y variable, okay? So this is going to be in list 3. I just put it right in this order, which means that these are the two possibilities because it's asking us which for X. So we're going to try X1, we're going to put in list 1, and we'll say X2, we put in list 2. So it says find and compare two correlation coefficients. Okay, so what I'm going to do is write down the R value and the linear model because it says we need to find the most appropriate linear model, and I don't like to go back and redo work that I already did. Okay, so the first thing we're going to do is a ln reg AX plus B for the first set, right? L1 with L3. So if you have an old calculator, this is exactly what it should look like when you go to do this process. You go to ln reg, and which is option 4 under the stat calculate menu, and then before you hit enter, you type in L1, which is second number 1, and then comma L3, so that this is your X list and this is your Y list. Newer calculators like mine prompt me. So it'll say, like, what do you want for X? What do you want for Y? And I'm going to tell it. Okay, so I'm going to write down the R. Okay, and then underneath it, I'm going to record Y hat. All right, and then the process is I'm actually going to repeat that. Ln reg AX plus B for L2 and L3 because I want to try this X2 with my Y variable, and my Y variable is already in list 3. So I'll get an R there and a Y hat. Okay, so we're basically going to be finding this stronger model. So whichever R value is higher, right, will be the stronger model. So closer to 1 or -1. So we're going to go stat. I've got the data in my calculator already, remember, okay? So this might be a time to pause the video, right? Put all of this in list 1, all of this in list 2 for weight, and all of body fat in list 3, okay? Now I'm going to go to stat. I arrow right to calculate. I select option number 4. List 1 is my first list, and I'm going to change this to list 3 by hitting second and the number 3. And then I'm going to go to calculate. Remember, old calculator people, it looks exactly like I wrote it down here with the comma and everything, okay? And then we hit enter, and we end up with an R value of 0.8869, which is great, okay? And then I'm just going to record this equation, which is 2.2215x minus 62.5573. Okay, so just in case that's the stronger of the two, we're going to keep that. If this happens to be the stronger, we'll use this equation for the following problems, okay? So let's take a look at the second relationship. So I'm going to do that one more time. I'm going to hit stat. I'm arrowing right to calc. I'm selecting option number 4. And this time, I'm going to use second list 2. So second number 2 with Y as list 3. And I'm going to calculate that. And again, since maybe you can't see this, I'm going to record that. That's R is 0.6966, which we now know is not as strong. But just to be consistent, I will record the model. You don't have to, but I think it's good practice, okay, to make sure that we understand how we would write this down. Okay, so these are our two models, but this R is stronger, right? So which is the better predictor then? Well, that would be list 1, or waist measurement, okay? So our waist measurement ends up being the better predictor because the R value is stronger. So let's rewrite our linear model just to make sure we are using the correct one moving forward. Okay, so here we have this linear model, and it says to explain the slope in context. So again, we're going to write that slope out. That's the number in front of x. And I'm going to use my units again. So remember that that was y over x. We just said that waist measurement is our better x variable. So our x is in inches, and body fat is measured in percentage. So for each additional inch in waist, body fat increases because it's positive, 2.2215%. And that's an interpretation of that slope. Okay? So now we're moving on. Predict the body fat of a person weighing 200 pounds with a 42-inch waist. So I put this information here because we weren't sure, and I didn't want to give away which is the better predictor. Now we know that waist measurement is the better predictor, and we are now predicting. So we are using y hat, and we are plugging in 42 for x. So I'm going to set it up. I'm going to leave it up to you guys to go ahead and solve that, since we did a few of these in the previous example. Okay, so you can go ahead and plug that in your calculator, and you can check that answer, all right? The solutions are in my packet online, so if you want to go back and look as well. This is the more important to me question because we will have to do this process. This says, what is the residual, so this is our difference, of a person who weighs 190 pounds, has a 39-inch waist, and 21% body fat. So they are telling us that this person, X, Y, their waist and body fat is 39, 21. So this is our XY. We now need to find y hat when x is 39. So we have to use the same exact y value. Okay, and we will get a y hat right here. So I'm going to go ahead and do that. 2.2215 times 39. And just so you guys know, y-intercepts can be negative. Remember, they're just starting points. It's obviously not possible for someone to have negative body fat percentage. All right, I accidentally typed this in wrong. Okay, let me just go ahead and hit enter again. So I got 24.0812. All right, and then finding the residual, I'm going to draw a line again, and we'll do the math over here. Y minus y hat. Y is the actual body fat, which was 21, and then we subtract. I'm going to go ahead and round that to 24.1, and we end up with negative 3.1. So again, that's negative. I guess I'm really boring. It's again another over estimate by 3.1% body fat. All right, that's my last example for Chapter 7. Hopefully this sets you up for some success on that take-home quiz. Remember, as always, let me know if you have any questions at all. Good luck.